Hey, good afternoon, everybody. Welcome to another UE Systems webinar. I feel like it's been a little bit since we've done one of these. We've been doing more product launch specific webinars, so it's kind of fun to get back to what we love to do, which is have customers and users of our equipment come on and share some best practices and some tips and tricks and all the good things. So that's what we've got for you today. So today we've got Robbie Seward is going to be talking about launching a robust CBM program using ultrasound, of course, as well as infrared. Low cost, low difficulty, two things that for sure define, ultrasound. We're always talking about how versatile, easy to use, and cost effective ultrasound is. So it's going to be great to hear that from Robbie's perspective. Robbie has been a power user of our ultrasound technology for as long as I've been around here, for at least the 12 or so more years, and probably before my time as well. So he's going to be a wealth of knowledge for you guys today. He's currently the asset management reliability specialist. He said basically the CBM guy at Jacobs, and so that's where he's at. And before we welcome Robbie in, just some typical housekeeping things. We are recording this. Robbie is kind enough to let us do that. So we will add this to the plethora of videos and recordings that we've got on our YouTube channel. So that'll be up there later today. If you haven't been to our YouTube channel, recommend you checking it out. We've got everything from short little videos about kind of how to do certain things with related to ultrasound to recorded webinars like this, and some longer form videos as well. So just a good resource for you guys. Just go to YouTube and just search UE Systems and you'll find our channel. We do welcome questions and participation, so you can ask those at any time. I'll be keeping an eye on those questions. We'll toss them over to Robbie throughout the presentation if it makes sense, if someone's needing some clarification on something. And then of course we'll hopefully have some time at the end. If we don't get to all the questions, which sometimes that's the case, we'll be sure to follow up offline and make sure your questions are answered. And then always like to remind you guys, we are doing this live. So if we run into any audio issues or any technical problems, heaven forbid my Wi-Fi drop or anything like that, we'll try to address it and fix it just as quickly as we can. But I think being able to do this with you guys live and as in person as we can be via our computers, I think it's worth that small risk of having some things go haywire on us. So with all of that said, I'm going to turn the screen over to Robbie, and Robbie will let you take it away.
There we go. Okay, I'm gonna try to show the right screen here. Let's see. I think it's gonna be that one. And
perfect.
Is that showing right? Okay.
Yep. Good. Looks good.
All right. So, well, Maureen already introduced me, but I'm Robbie, and I'm the asset management reliability specialist, or one of them, asset management reliability specialist for Jacobs, and I'm CMRT, infrared level 3, ultrasound level 2. I've got many others, but those are the ones that are relevant, that are related to this webinar anyway. So, and I've been doing this for quite a long time. I'm not good at talking about myself. So this is a webinar on how to launch a robust CBM program using ultrasound and infrared. And they are low cost and a lot less difficult than others. All right, what is CBM? Well, it's condition-based maintenance. CBM is maintenance performed on assets or equipment that is based on the actual condition of the assets. CBM is optimized based on asset condition rather than using a calendar-based or operating hours-based approach. CBM utilizes a range of non-invasive technologies, equipment, and sensors for determining the condition of an asset. And CBM technology or equipment is used to discover potential asset failure and causes early so repairs can be scheduled in advance. Each CBM technology has strengths and weaknesses depending on the failure modes being investigated. Right. Why do you need a CBM program? Well, most organizations want and need their assets to reliably function as they are intended, so their goals, production and safety goals, can be met. Reliability-centered maintenance, RCM, is a systematic and disciplined process for establishing the appropriate maintenance plan for a system or asset. 2, minimize the probability of failure, contribute to process safety, help preserve system function, and help assure mission compliance. CBM program, route-based or online, is a primary component of a RCM program. NFPA 70B 2023, the standard for electrical maintenance, has mandated a documented electrical maintenance program, as well as annual infrared thermal inspections of all electrical equipment. So because they've already done that, it's a mandate, it's a standard, so why not build on that and create a better program? CBM program decisions. When starting the CBM program and to solidify the types of monitoring that need to be performed, questions must be answered, decisions made. What are the most important assets and equipment types that you have at your facility? How often are those assets, how often are they failing? What are the most common failure modes? Why are they failing? Okay. Which CBM technologies will provide actionable data for all of the failure modes? So it's not a complete list by any means, but it's some of the primary things to consider. All right. CBM technologies and options. The most common CBM technologies and tools include vibration analysis, infrared thermography, ultrasound, contact and airborne, oil or lubrication analysis, motor current signature analysis, process or equipment operation measurements, stuff like pressure and flow. They're also used in a CBM program. CBM technology or data and process measurements can be collected via route-based efforts or by using permanently mounted sensors with programmed data collection intervals or set points. The latter is typically called continuous or online monitoring. I've also heard the argument that continuous monitoring as it pertains to CBM isn't continuous technically because the data is being collected at intervals or set points. You can use the term that you're most comfortable with for the type of monitoring that includes those permanently mounted sensors and automated data collection. CBM technologies on the PF curve. You can't go through any of these webinars or anything without seeing this PF curve. So what I just wanted to focus on was the predictive domain there and the order that these tools show up in. And ultrasound is at the top of the list. It finds problems at the highest frequency, higher than vibration. So it comes before vibration. So ultrasound, vibration, oil analysis, infrared, and MCE, or motor circuit evaluation. The infrared and MCE, I question. This is where I found MCE was after infrared, but they may switch around with infrared. I'm not sure. Just depends. So another note is you'll hear the term PDM, predictive maintenance, and it's interchangeable. It can be used interchangeably with CBM. I think the term CBM is more accurate because the equipment doesn't technically predict anything. The equipment simply discovers a fault in an asset or reveals its condition earlier than we can without using the equipment. So I like to use condition-based maintenance rather than PDM. Like I said, it doesn't really predict anything. All right. So customizing CBM plan. Not all organizations have the same asset mix or the same problems. So it's a good thing that CBM programs aren't just one size fits all. Some people try to make it that way. But in addition to questions and information on the previous slides, there may be more considerations that are unique to your organization. Bottlenecks, specialty or old equipment, long part lead times, etc. It's important to choose CBM technologies that will help address the greatest range of issues and as early as possible in the beginning. Some technologies are very, linear. They only do one thing. So the fewer technologies you can use that find different problems, the better. The two most versatile CBM technologies are acoustic ultrasound and infrared. Generally, they're the least expensive CBM equipment to purchase. And they're the easiest to learn and build CBM programs with. And they are highly complementary technologies. They work well with each other. The range of issues will be discussed in greater detail a little later. By complementary, I mean that ultrasound and infrared can confirm each other's findings in some cases, and in other cases, ultrasound or infrared may work where the other doesn't perform well. And I'll show examples of that later. All right. So the vibration technology standard. Vibration technology is the oldest and most widely known CBM technology. Vibration technology is the go-to technology for most CBM consultants. Therefore, starting a CBM program using vibration monitoring is going to be the most common recommendation. So vibration upside. Well, the most common recommendation. So when you're a vibration analyst, then most of the time, that's what you're going to, that's exactly what you're going to recommend. So one of the vibration upsides is it provides detailed data on rotating assets that operate at greater than 600 RPM, bearings, motors, pumps, and gearboxes, and it provides that information in advance of failure. It's very useful at helping to identify the root cause of an asset failure. And it's also very good at identifying structural and resonance issues. So the downside is the most popular name brand full-featured vibration equipment is very expensive. It requires a lot of training and experience to get the most out of it. And it is limited to mainly mechanical monitoring and fault detection. So when too much focus is placed on a single technology, like what some people do with vibration technology, there's a tendency to want to emphasize that technology over all others. I've seen plenty of organizations and people discount the value of ultrasound and not use infrared or ultrasound to their full extent. I highly recommend performing a full and honest analysis of your failure modes and needs prior to assuming that vibration is the best way to start your CBM program. So, a little bit about ultrasound technology. Acoustic ultrasound is the first line of defense when talking about bearing failure monitoring. Mechanical problems such as friction in bearings manifest at very high frequencies and progress to lower frequencies as the problem worsens. Acoustic ultrasound takes measurements at higher frequencies than typical vibration monitoring. Because acoustic ultrasound can detect faults earlier than vibration, it allows for more time to plan for repairs. Vibration technology is still better at providing more fault detail that can be used to help determine root cause, but more detail is not always needed. It's a good idea to use ultrasound to initially detect a defect and follow up with full spectrum vibration technology if more detail is required or preferred. Ultrasound is also used in the detection of other faults or problems that do not directly relate to rotating assets like air, gas, steam, vacuum leaks, valves, electrical faults, etc. Ultrasound detects mechanical issues at approximately 30,000 hertz, 30K hertz, where typical vibration analysis starts detecting defects at approximately 20,000 hertz. So that's where the ultrasound shows up a little higher on the PF curve that we saw a while ago. When I say that more detail is not always needed, I mean that in a lot of cases, knowing that there's an outer race fault in a motor outboard bearing may be good information, but most techs are going to replace the motor and send it out for repair rather than replacing the motor outboard bearing. And I highly doubt that a tech is going to replace the outer race of that outboard bearing. So, you know, the tech's going to replace the whole bearing if that's the repair option decided on. So that's the reason. Stuff like that, you don't always have to have all the detail that vibration analysis can show you. So starting a program. By following the NFPA 70B 2023 electrical maintenance standard, which mandates the infrared inspections on all electrical equipment annual, and lists acoustic ultrasound as an option for electrical inspections of equipment operating at greater than 1,000 volts, you're already on your way to launching a good CBM program. So some example benefits of the ultrasound is the cost of a top-end ultrasound probe is about half the cost of the most popular full-featured vibration analyzer. It's also very useful for assisting with proper bearing lubrication. We'll talk about that a little later. And it's good for monitoring trending slow speed bearings, less than 600 RPM, where vibration monitoring is not nearly as effective, especially at 300 RPM. Your vibration is pretty much not effective at all. Repairing the findings from a single compressed air leak audit at a medium to large site can easily pay for the equipment, plus plenty of additional savings. More about starting a program. Ultrasound and infrared capability reference. So electrical, that can be done. It's primarily known, infrared is primary for electrical, and ultrasound is also good for electrical too. It's good for the high voltage, and it's also good for checking cabinets before they're even opened, just as a safety precaution. Oh, mechanical. as far as bearings go. Ultrasound would be primary, and then infrared. So ultrasound is going to pick up sounds and record the decibel level, and of course, whenever problems occur, it creates friction and therefore creates heat, and infrared can see that. Lubrication assistance, that would be ultrasound. Ultrasound is very good at lubrication. Compressed air and gas, vacuum leaks, that's all ultrasound. Valves, ultrasound and infrared both. So depending on what type of valve, what kind of system it is, ultrasound can work with all of it, but a lot of it infrared can too. It's like, you know, if there's temperature differences, then you can also see it with infrared, see valve operation with infrared. Steam, ultrasound and infrared both, same thing, you know, same for the same reasons. Ultrasound hears steam traps operating and stuff like that, where in infrared, you know, can see the temperature differences between one side of that steam trap and the other. Building envelopes, that's primarily done with infrared. There might be some ultrasound in there, but that's primarily going to be done with infrared. And roofs, that's primarily going to be infrared. HVAC systems, that's going to be infrared and ultrasound both. Both of them are going to be good for that. So electrical infrared inspections are reports, and reports are required annually by NFPA 70B. It's a good idea to scan MCC, switchgear, etc., for arcing and tracking with ultrasound prior to opening doors for the infrared inspection. You know, for the mechanical part, bearings between ultrasound and infrared running bearings, ultrasound is the primary, and since friction is the cause of ultrasound in bearings and friction causes heat, infrared can also identify a bearing defect. So, so lubrication, ultrasound is definitely the uncrowned leader in lubrication assistance. So I think I've covered most of this already. Yep. Valves, ultrasound is good for listening for valve operation and flow before and after a valve. Infrared is good for viewing flow before, or you know, before, after, or sometimes even inside a valve if the fluid is hot or cold in comparison to the atmosphere. So here's a bunch of example finds. So this is a ultrasound. This is slow speed bearing. This is you know, hearing is believing, you know. So this is a very slow speed bearing. Vibration you wouldn't even use vibration to monitor something like this. I don't know, this bearing might have been running maybe 30 or so RPM, but this is, hopefully you'll be able to hear this. This is what it's going to sound like, or this is what it sounded like whenever I found this. And I only checked this bearing because of all the debris and stuff that shows that you can see down here at the bottom of this bearing. That's what drew my attention to it. So this is what it sounded like. Maybe that's what it sounded like.
Yeah, we're not hearing it, even though yesterday when we tested this, we did. So
yeah, and I think it's something to do with my audio sharing here. So and I'm not exactly sure how to fix that now. I found it yesterday.
Best laid plans.
Yeah, I found it yesterday. It was easy. Um, well, it was real easy yesterday. Well, crap. Well, I don't know what to do about that.
Yeah, are you using the computer audio or you got the headset on?
I'm using the computer audio, and
Okay.
yeah, it was not it was, I spotted it.
You know what? I wonder, had we switched into this presenter mode? I wonder if it's because you're off your other monitor. Maybe it's not playing. Oh, let's see.
Hey, there we go. How about that? So, all right. So I was using the wrong screen. Okay. So that's what that bearing sounded like whenever I found and this is what it sounded like after the bearing was replaced. So that little tinkle you hear is that spacer going around there. It's just kind of rolling on the shaft, but the flat tire sound is gone. All that noise that you heard with that flat tire sound, that's all it was that little spot right there. So, the damage shown on the bearing, right, it doesn't look like much. In a dry bearing, as this one was, the bearing was dry also, with a big load on it, the rolling elements continuing to roll over that spot would have continued to peel the material from that area until the equipment failed to operate. It would have happened. Even as small as that is, the failure would have happened. And as much as you like to think that you can always predict how long it's going to, how long a piece of equipment is going to run, that's a crapshoot at best. So it's best to replace it as soon as you find it, or as soon as you can. All right. For something a little bit more, involved than just a simple little bearing, this is a whole big overhead conveyor drive. And whenever I first saw this, I mean, this was fast. This was within 3 months time period. So from December to April, it went from 17, that the motor front bearing, this is on the front motor up here. So that decibel reading went from 17 to 44, just that fast, over that 3-month time period. And so the motor inboard bearing ultrasound decibel reading jumped up dramatically between the quarterly routes. The baseline was at 15 decibels, and the low lubrication alarm is set at 23 decibels, which is 8 decibels over the baseline. And the high alarm was set at 35 decibels, which is 20 decibels over the baseline. The last measurement was 44 decibels, which is 9 decibels over the high alarm setting prior to replacement of the drive assembly. So this drive unit is factory assembled and is not made for parts replacements, like replacing the motor in the field. So having all the data that vibration analysis could have provided wouldn't have been a benefit, really, because you have to replace the whole unit. So this is what happens This is what happens after replacement. So after replacing the drive unit and running it for a while, unloaded, the decibel dropped from the previous 44 decibels down to 22.5 decibels, right here. And we took new readings after it had been running for 36 hours while it was loaded, while it was in normal operation. And it dropped right back down to the 15 decibels that it started out with. So okay, this is friction brakes. This is something I discovered kind of on accident because I had sensors mounted on these, and I was trying to listen to the bearings, but just so happened the sensors picked up these friction brakes whenever they were out. So out of adjustment friction brakes are another example of a fault that ultrasound can detect, because, I just discovered it by accident, but they have a distinctive sound when they are operating properly. And so anything out of the ordinary is most likely a problem. So it was found that the brakes were supposed to have been adjusted during a PM. It shut down, but they weren't adjusted correctly. Of course, we had to retrain all the technicians on setting the brake gaps right. So this is what I heard. Okay, this is what I heard whenever we listened to it. Or all right, that's whenever that motor.
I heard like the very beginning, and then it got real faint. So I don't know if you can turn your speakers up a little higher.
Oh. Okay. Let's see, I'm not sure how I can do that. Huh. I don't know.
That's okay if not.
Let's see. All right, I can turn my speakers up. Let's see. Let me try it again. See if you can.
Yeah, that was loud at the beginning, and then it kind of went away.
Gosh, it's doing it. It did it again. Huh.
Well, we heard it better at the beginning. Maybe maybe it's a shorter sound file than I'm thinking, but then they're just kind of silent. So I'm not sure.
Oh, well, there's a sound at the beginning, and then it quietens off whenever it's running, and then there's another sound at the end.
Oh, okay. Maybe
that's how.
Sorry.
Yeah. So yeah, that's the brake releasing and the brake re-engaging at the beginning and the end. And you're not even supposed to hear that. All you're supposed to hear is a little click. So this is what it's supposed to sound like. That's what it's supposed to sound like. So it's supposed to just be a click and then a running sound and a click to start and stop. That's all you hear is a click to start, click to stop. If you hear that squealing, that noise that you heard a while ago, then there's a brake out of adjustment. It's a bad brake. Brakes aren't supposed to operate like that. So All right, and this is how I even, because we weren't listening to it, we just had sensors on it. So I ended up recording the audio for it, but this is, or taking readings on it. So this is how it, I can just show you. I mean, it just goes above the warning right there pretty fast. And then after the brakes were adjusted, it dropped right back down to baseline. Same way with this other one over here. It had actually dropped down a little bit, and then it went above the low alarm, and we adjusted the brakes, and it went right back down to baseline. All right. So this is just showing a little bit of how ultrasound and vibration, it compares to each other, the bearing diagnostics. So ultrasound, it can show similar things that vibration does. These are the exact same motors, exact same bearings, and both of them show a discernible harmonic at 93 hertz. And 93 hertz, that's going to be an outer race fault. So both of them can show that outer race fault. When it comes to bearing diagnostics, ultrasound and vibration diagnostics can complement or validate each other. The ultrasound data on the left, it is displayed in a waveform. That's the ultrasound data. The vibration data on the right is displayed in a spectral format that's derived from an FFT. So although the harmonics are discernible in both formats, the spectra in the FFT, the spectra in the vibration data, is overall, it's more useful for, more detail, for providing more information. It's a little bit more useful. So with just a little bit of practice, though, bearings with a potential problem can be identified by sound alone. As this is what this bearing actually sounds like. So, and this is what a good bearing actually sounds like. So, I guess so basically, if you hear anything other than just a white noise or just a slow, smooth static, then there's a problem within that. There's a problem in the bearing. It wouldn't necessarily that you can't listen to it and tell that there's an outer race problem, but you can tell that there's a problem. So, and sometimes that's all you need to know. All right, bearing lubrication. So depending on the study that's referenced, about 60 to 90% of bearing failures are found to be lubrication related. Out of those lubrication related failures, most of them are due to over or under lubrication. And out of the over or under lubrication related failures, most of those are due to over lubrication. It's been proven that time-based lubrication PMs, which are generally recommended by equipment manufacturers, are mostly inadequate or potentially even damaging. So the application of the 3 shots of grease into a bearing on a monthly PM basis without monitoring the condition of that bearing can cause damage, over or under lubrication, either way. The images show some obvious over lubrication issues. When a bearing seal is broken, like right here in the middle, the grease escapes to the outside of the bearing, and it collects contamination, and it gets pulled back into the bearing. So it causes damage to the internal elements. It's just as important to use the correct grease type also, and not to mix grease types. The one on the right there, is showing that red grease, and that is not a typical motor bearing grease. So the use of ultrasound assisted lubrication changes the time-based method of lubrication into a condition-based method. So only lubricate when necessary and apply the correct amount of grease. This is typically accomplished by listening to the sounds and recording decibel baselines when first creating a route, then applying lubricant when the noise climbs about 8 decibels over the baseline, and stopping lubrication when the decibels or the noise starts dropping. So good record keeping of the frequency and amount of lubrication added can be used to determine the accuracy of the manufacturer's recommendations and cost savings. So engineers have spent a lot of time using bearing lubrication calculators to get the right amount of grease in a bearing on a time-based schedule. In my experience, it just doesn't really work. There are too many varying circumstances that can't be accounted for. Ultrasound meets those bearing, meets bearing lubrication in real time, regardless of how often or how fast or how loaded that equipment runs. So sometimes ultrasound, where you would think it would work, doesn't work, or there's other reasons why it didn't work. So I attempted to use these big slow traction wheels. They're in the overhead of an automotive plant. And the traction wheels range from about 24 to 36 inches in diameter, and they turn at approximately 8 to 20 RPM, way slower than vibration can pick up. They contain 2 opposing wheel bearings, upper and lower, that are packed with grease prior to installation, and there's no way to provide additional lubrication while the conveyors are operating. Basically, disassembly is required to repack the bearings. There's no way to lubricate the bearings, period, even if the wheel was stopped. So I tried, like I said, I tried ultrasound, putting a sensor on top of the shaft up there, on top of the shaft that runs through the middle and up into the overhead. But because of all of the noise going through this white steel, the ultrasound didn't work out too well. The infrared is what did it. So I could see it with the infrared. I could see the temperature difference between that center hub and the outside of that wheel. And it showed a temperature. What we ended up figuring out was any temperature difference at about 1.5 degrees between this hub where those wheel bearings are and that outer and the outside of that wheel. If there's about a 1.5 degree temperature difference, then we had to replace those bearings or pull that wheel down and repack those bearings. So just that 1.5 degree temperature difference, this is what happens. That the lower bearing, what happens is the heat in the overhead, oil tends to run out of the grease, and this is the lower bearing, so it still had wet grease in it. It still had wet grease, but because it was carrying all the load, it still was damaging the bearing race, bearing races. This is the upper bearing. So all the oil had run out of that grease. The grease had basically turned to dust, and this is how the bearing came out, just in pieces. It had wore so much that there was little knobbies on the end of the rollers there. So anyway, that's how, those big, those big wheels that were in the overhead of an automotive plant, they will shut down a production line. So they're very important. All right, here's some infrared mechanical things to show you. This is a belt alignment issue, so it's real easy to see. I mean, you could see it just with the camera itself. You could see the belt running to the outside, but you can also see the friction on the on that bearing sheave, on the outside bearing sheave right there. So you can see where it was warm, getting warm. That bearing was running to the right. This is a vibrating conveyor. So these bearings, these are eccentric bearings. So they run and they are, they run eccentrically. So they're vibrating, and so you can't even stick a probe on it or a sensor. It would just knock a sensor off. So you can't really do anything with them other than use infrared. But you can see on this one where the left bearing definitely needs attention. Whether it's lubrication or there's a bearing problem, I don't know. I can't tell with infrared, but I can tell that there's a problem that needs to be investigated. All right, this is an example of steam. I can tell that steam trap is not working because it's cold. There's no way it can be working because steam traps they only work whenever they come up to temperature. So what happened is condensate had backed up through that through that trap. You can see where the steam is meeting the steam here is meeting the condensate. So I had to open up the valve after that steam trap to get that to drain and get that steam trap working again. So these are conveyor bearings, like chain-driven conveyor or belt-driven conveyor rollers. The roller bearings, they stick out like a sore thumb. You can stand back and look down a long conveyor and just see every roller that's bad. It does not take a lot of training for that. All right, here's a boiler end cap. There's a shelf in this boiler end cap, and this is what I saw. Saw the heat rising in this thing. I saw the gasket on the outside of that end cap. The gasket right there was leaking. And what happened, we opened up that door, opened up that boiler door, and all that scale build up down here. That was what was holding that heat on the boiler end cap. All that scale built up, and basically it was the whole problem was caused by poor chemicals. Not taking care of the boiler water right. So anyway, that whole door had to be replaced. Okay, this is a gearbox that I'm showing it mounted correctly here, but it looks like it's mounted correctly, but it's not actually. It's mounted at an angle. So gearboxes are set up to where they either mount, you can operate them horizontally or vertically, and the oil level changes depending on which one it is. But so the oil level for this thing was set for a horizontal mount, but the gearbox was actually mounted at an angle, at just about a 45-degree angle, like, if you can see my mouse pointer, about like that. So what the problem was is because of the oil level that was in there, oil was not carrying up to the top, up to this worm gear, all the way up here to the top, because that was the highest point. It should have been up here. That's the way it was. That's the way it was mounted. So we ended up having to change the mounting positions of those motors and gearboxes. All right, and these are some typical electrical deals. Okay, just typical exceptions that you would find just about anywhere. just about in any infrared inspection. So loose connections, overloads. This is an overload because you can see the temperature carrying, or it's got a higher load on that phase anyway. And then your fuse, probably a connection issue or either it's a wire connection issue or the fuse clip right here. One of the two is causing that heat. So things like these, like transformers, you can measure, you can trend temperatures on transformers. Here's another example of a fuse here, or breaker. This is a breaker. So that's getting hot, and this is high voltage here. So you may have been able to hear this with ultrasound, but there's a bad connection there too. There we go. So what do I gain out of all this? Electrical and mechanical maintenance excellence. Implementation of ultrasound and infrared inspection programs can discover the widest range of potential faults on the widest range of equipment, and with a very fast ROI at a lower cost than any of the other technologies. Because ultrasound technology works at a higher frequency than typical vibration technology, faults can be detected earlier, higher on the PF curve, and repairs can be scheduled farther in advance. Increase in asset reliability improves productivity and safety, and which equals maintenance excellence. Safety. The use of ultrasound and infrared detects potential equipment faults while equipment is running with no intrusive contact with the running equipment. Not to mention the direct relationship between having reliably operating equipment and safety. You know, the more reliable your equipment is, the safer your place is. Okay. Reduced cost example is like using the statistics-based method for calculation for infrared, which is what insurance companies use. Infrared inspection of a large site, which is classified as greater than $25 million, containing just 10 critical or serious and 20 intermediate minor exceptions, and assuming only about half of those would result in downtime, the average cost savings of just those few is $50,000, which is more than enough to buy a couple of nice infrared cameras. So the good news is, even with conservative estimates, you're achieving significant savings. So implementation may be challenging. You know, even as easy as it is, it can still be a problem. Your organization may need help with kickstarting a condition-based maintenance program. You know, your organization doesn't have quality or calibrated equipment or trained personnel. Your organization may need technical consultation concerning fledgling infrared or ultrasound program to verify proper analysis and record keeping. So even though you have people doing, you may have people doing this program, they may still need help. They may still need to bounce some problems that they find off of somebody else. Your organization may need a leak, audit, compressed air, steam, or vacuum system, if energy costs, rise disproportionately year over year. If your energy costs are going up, but you're not running your equipment anymore, then you might have a problem there. Your organization may need consultation or other general help with just becoming compliant with NFPA 70B standards, because that's a big deal for some places. So an impressive CBM program is attainable. So NFPA 70B requires that the creation of electrical maintenance program and an annual infrared inspection and annual infrared inspections of all electrical equipment, expanding infrared and ultrasound inspections to utilize all their capabilities is a great next step in the creation of a impressive CBM program. So these may be new or daunting tasks to some. They're not for the asset management group at Jacobs. We have experienced condition maintenance engineers, professionals who are certified in multiple CBM technologies, project managers, or other reliability engineering support. And we are ready to help your organization if you need us. And here's how you can contact me or my group. And that's pretty much all I've got. Sorry for the couple of little snafus that I had there with the sound and stuff.
No, that's okay. As we said yesterday, it's always kind of a toss-up whether those audio files are going to work on this platform. It's kind of frustrating, but we did our best. So that was great, Robbie. Thank you so much. I do have a couple quick questions, and if people want to toss in a few more, I know we're almost up against time here. But Robbie, one thing I would ask, because you've been doing this for so long, and you've probably helped get these programs up and running at multiple different plants throughout your career, is, everything you just said is awesome and seems like a no-brainer, right? It all seems to make all the sense in the world, but that's easy when you're kind of preaching to the choir. So what kind of advice would you have for people who believe in this and want to get something like this started at their plant, but they're, hearing the typical, no, that's not how we do things. We'll keep doing things the way we always do it, or we don't have the manpower to take on, these technologies and things like that. What would be kind of your quick, which I know it's not a quick answer probably, but if you had to give a couple quick thoughts on that, what would you say?
Well, if it were me doing it all over and had to fight it, luckily I had management that kind of pushed me into it. That's how I got started. But if you don't have that type of management where and they're stuck in their way of doing things, then it would be my suggestion to contact somebody like me, or that can provide, if you have those kind of problems, you could contact somebody like me that, say you have a repetitive, piece of equipment, that's causing a problem. You could, I can provide maybe, or somebody like me, whatever, can provide some examples of how the equipment, this equipment or any other equipment really can help find those problems ahead of time. Basically, most of the time your management is going to want to, show me the money, how is it going to benefit me? I can provide some examples of the infrared or ultrasound. It's pretty easy to find. It's easier than what you would think. I know it doesn't sound easy, but it's easier than what you would think to find where you can show management where the benefit is financially. So that's where, the hardest part is to try to get them to see where it's going to benefit them to spend $20,000 on an ultrasound tool or $10,000 on an infrared camera. So to some places that's a lot of money. To some places it's not very much money, and they'll do it. But some places it is a lot of money. So you have to show them the benefits of it. And those two, I showed a couple of little examples. Well, one actually financial, finance example, but I could give you a better one. Anyway, sorry, I'm just running on here.
Oh, that's okay. And I think what Robbie's saying is go find him on LinkedIn and become a connection with him so you've got Robbie in your back pocket when you need to call on him for some help. But honestly, that is a great, recommendation. And I think, there's a ton of resources on LinkedIn of people like Robbie who I think are more than happy to kind of help share their journey and their tips and successes to kind of help you out. So I think that's a great kind of plug for the LinkedIn community. But well, Robbie, this was fantastic. I really appreciate you taking the time today to go through this. Amazing examples that you had in there that I think everybody can hopefully take something back with. So appreciate you guys all joining us. I hope everybody has a great rest of your day, and we'll catch you guys later.